In 2009, Toyota recalled approximately 9 million vehicles globally in response to reports of sudden, unintended acceleration. The recall was one of the largest in automotive history. The cost, indirect recall expenses, legal settlements, regulatory fines, and brand damage, exceeded several $billion. The sequence of events that led to the recall illustrates one of the most expensive patterns in quality management: the cycle of treating symptoms rather than causes. Floor mat interference was identified early as a potential cause. Floor mats were redesigned. Some incidents continued. The accelerator pedal mechanism was then identified as a potential cause. Pedals were replaced. Incidents continued in some vehicles. The investigation eventually extended to electronic throttle control software, a potential cause that had been present throughout, but was more difficult to diagnose than the physical components. Every solution that was implemented was genuine. The floor mat was a real contributing factor. The pedal mechanism was a real contributing factor. But in the urgency to respond to a safety crisis, the full causal picture was never assembled before solutions were deployed. Root cause analysis, done rigorously, done completely, before solutions are designed, is the discipline that prevents this pattern. And the fishbone diagram is one of the most powerful tools available for doing it. Welcome to the Catalyst. This is episode 25. Today we cover fishbone analysis, also known as the Ishikawa diagram and the cause and effect diagram, where it came from, how to draw one, the 6 categories of causes it structures, and how it connects to a complete root cause investigation that produces solutions that last. The fishbone diagram was developed by Kaoru Ishikawa, a Japanese quality management engineer and professor in the 1960s. Ishikawa was a central figure in Japan's post-war quality revolution, the movement that transformed Japanese manufacturing from a reputation for poor quality to a reputation for exceptional quality within 2 decades. Ishikawa developed the diagram, which he presented formally in his 1968 book, Introduction to Quality Control, as a tool for organizing the collective thinking of quality circles, groups of frontline workers who were tasked with identifying and solving quality problems in their area of work. The diagram was first applied systematically at the Kawasaki Iron Fukiai Works in 1952, and its adoption spread rapidly through Japanese industry. It became one of the 7 basic quality tools, a set of analytical techniques recognized by the American Society for Quality as foundational to quality management practice. Today, the fishbone diagram is used across industries including healthcare, aerospace, pharmaceuticals, financial services, and software development. The fishbone diagram gets its name from its appearance. The problem statement, the effect being investigated, appears on the right side of the diagram, representing the fish's head. A horizontal arrow points toward it, representing the spine. From the spine, diagonal arrows branch out, representing the main categories of potential causes, the bones of the fish. From each main bone, further branches extend, representing specific causes within each category. The most widely used framework for organizing the main bones is the 6M model, originally developed in manufacturing: machine, method, material, measurement, man or people, and Mother Nature, which refers to the environment. Machine encompasses equipment, technology, tools, and infrastructure. Any failure, miscalibration, or design limitation in the physical or digital systems involved in the process. Method encompasses the process design itself, the sequence of steps, the procedures, the workflows. The question here is whether the process, as designed, is capable of producing consistent quality outcomes. Material encompasses the inputs to the process: raw materials, components, data, information. Quality problems that trace back to material issues are often the hardest to diagnose because the material may appear acceptable on standard inspection. Measurement encompasses the systems used to monitor and evaluate quality. A process can appear to be performing correctly because the measurement system is inadequate, not because the process is actually performing correctly. People encompasses the human element. Skills, training, judgment, communication, and behavior. People-related causes are important to investigate carefully and objectively. The goal is to understand systemic training or communication failures, not to assign individual blame. Environment encompasses the physical and organizational conditions in which the process operates. Temperature, humidity, noise levels, organizational culture, regulatory context. Environmental causes are often overlooked because they are stable enough to seem like background conditions rather than variables. A fishbone analysis is most effective when run as a collaborative, structured exercise with a cross-functional team that includes people with direct knowledge of each of the cause categories. The exercise begins with a precisely defined problem statement. Not quality is poor or the project is delayed, but the error rate in the invoice processing team increased from 1% to 4.5% between January and March. Specificity in the problem statement prevents the analysis from drifting into generalities. The team then brainstorms potential causes under each of the 6 M categories, asking for each one. Could this be contributing to the effect we have defined? The goal at this stage is comprehensiveness, not certainty. Every plausible cause is added to the diagram, even if its contribution seems uncertain. Once the diagram is populated, the team applies the 5 whys technique. Developed by Sakichi Toyoda, the founder of Toyota Industries, to each significant potential cause. Ask why the cause exists. Then ask why that answer exists. Then why again. 5 iterations of why applied rigorously typically reveal the root cause rather than the surface symptom. For example, why did the error rate increase? Because the team was processing invoices without adequate verification checks. Why were adequate checks not being applied? Because a new processing system had been introduced and the team had not been fully trained on its validation features. Why had they not been fully trained? Because the training program was delivered during a period when 2 experienced team members were on leave and the remaining team was under pressure to maintain throughput. Root cause. The change management process for the new system did not account for capacity constraints at the time of deployment. A solution at the surface level, retrain the team, might have some effect. A solution at the root cause level, redesign the change management process to include capacity planning, would prevent recurrence. 5 things to carry from this episode. 1. Fixing symptoms is expensive. Every solution that addresses a symptom rather than a root cause produces temporary improvement and then recurrence. The cost of repeated symptom treatment, in time, money, and customer trust, almost always exceeds the cost of thorough root cause investigation. 2. The fishbone diagram organizes complexity into navigable categories. 6 categories of causes: machine, method, material, measurement, people, environment provide a comprehensive framework that prevents teams from overlooking entire domains of potential causation. 3. The 5 whys technique is the partner tool to the fishbone diagram. The fishbone maps the potential causes. The 5 whys drills down into the most significant ones to find the root. Used together, they produce a complete picture. 4. Root cause analysis requires a precisely defined problem statement. vague problems produce vague diagnoses. The investment in specifying exactly what the problem is, when it occurs, and how it has been measured is the most important 30 minutes of any root cause investigation. 5. Your action. Identify one recurring problem in your work that has been addressed before but keeps coming back. Draw a simple fishbone with the 6M categories. Populate it with causes from each category. Then apply 5 whys to the most significant ones. The root cause you find will almost certainly be different from the symptom you have been treating. Coming up on episode 26 of The Catalyst. The final episode of this series, we cover the financial calculation that every business decision maker needs to understand. Break-even analysis. The framework that tells you exactly how much you need to sell before your business, product, or project stops losing money and starts making it. Simple in concept, powerful in application, and more widely misunderstood than almost any other financial tool. Stay tuned.